Okay, and question 5 is actually asking you to recall some C2 knowledge. So it says the diagram has a circular plot of radius 3, which they've shown me there. Alan wants to use the minor segment as a plot for the flower bed. They've helpfully told you that bit there. And it has edging of 13.5 meters, of which he tends to use the form perimeter of the shaded area below. The angle subtended from the center of the circular plot is denoted by theta radians. So basically, they want me to tell you what that perimeter there is, okay? So going around that. Now, if I was looking at this just logically and just thinking, right, okay, well, I know that is going to be an arc length there. That's going to be r theta. That's the formula we learnt in C2. And then this bit here, I would have potentially looked at actually using cosine rule here because we know that's 3 meters and that's 3 meters, and then that's the opposite from that. But if you look at this bit here, it's telling you to use sine because it says show that it's got sine in it. And then also theta has been divided by 2, so I'm going to divide my theta by 2, and I notice that I make a right angled triangle. Now this bit here is opposite the angle, and this bit here is the hypotenuse, so that means I'm going to use sine. Okay, so to work out the opposite, I'm going to say sine of the angle, which would be theta over 2, because I split it in half. I'm only splitting it in half because they tell me that bit there is equal to the opposite, which I don't know, so I'll call that op, over the hypotenuse, which is 3. So then I'm going to get 3 sine theta over 2 is equal to the opposite. But bear in mind, that only finds half of it, so I'm going to have to double that to find that length there. And then this is just r theta, and the radius is 3, so this would be 3 theta. Okay? So therefore, the perimeter would be equal to arc length plus the straight. You don't have to write it in words. I like to write it in words, though. It just makes me feel a little bit more confident in what I'm doing. The perimeter we told was 13.5, so that would be 13.5 equals the arc length, so 3 theta, plus the opposite, which was 3 sine theta over 2, but doubled because there's 2 of them. There's that one there as well. So that would be 6 sine theta over 2. And then, to get that, they want theta by itself, they want me to divide everything by 3. So 13.5 divided by 3 is 9 over 2, which is 4.5, which is great news, it's that. So 4.5 is equal to theta plus 2 sine theta over 2 as required. Okay, so I did that on the paper just so you could sort of remember or see the picture as well. And you'll see there that I've got it there. Okay, now for part B, some of you let that affect your part B, and even if you can't do part A, you skip on and you do part B anyway. That's not related to being to do that. They tell you what that formula is there, and they told you what the formula is here. So we're told here for part B that theta 0 is equal to 2.5. Okay, so then I need to go and find theta 1, theta 2, and theta 3. Now we're used to seeing this as like x2, x3, etc., but they've just done thetas. Now the way that we do it is we're going to make sure we're in radians mode first of all. Mode 3, Y, sorry, that's table mode, I've been using Simpsons rule. Shift and setup, and then 4. Why? Well, because we've got sine, and in C3 we work in radians unless we can see degrees reference anywhere. And I can't see degrees reference anywhere, so we're using radians. Okay, we press 2.5 and press equals into the calculator, so there's my answer. And then we're looking at this formula here, and wherever we see a theta n, we change that to ans. So it's going to be 4.5 minus 2 sine, and then it's going to be ans over 2. Ans over 2. Now, I'm not expecting a huge amount of variation between these answers. I'm expecting it to stay near enough 4.5. I'm not expecting this to go like 3 or like 10 or anything. So what do we get for this? 2.6. So I have to show at least 2 decimals in every question, but you don't round them. So 2.602 blah, blah, blah. Press equals will give you the next one. 2.5723 blah, blah, blah. Press equals again. Gives me 2.58 to 2 decimal places. And that's the one I do actually round to 2 decimal places. It says prove that this value of theta is correct to 2 decimal places. So from here, I'm going to really think of theta 3 as 2.580 because that will help me work out what the lower bound and the upper bound is. Okay, so take away 5, add on 5 onto the back end of that. So we're going to do f of 2.575, and we're going to do f of 2.585. Okay. Now, when we sub that in, that goes back to this formula here. Okay, and we're supposed to be getting the answer 4.5. So remember that. So we're going to get 2.575 plus 2 sine, and then it's 2.575 over 2. And that should come, one of these answers should be above 0, not above 0, but above 4.5, and one should be below 4.5 from there. Okay, so 2.575 plus 2 sine, and then 2.575 over 2 equals, excellent, 4.49, so that's the one under, so 4.49 blah blah blah. If you wanted to, you could maybe take the 4.5 over, but there'd be no need to do that. And then the same here, again, show what you're doing, just make it really nice and obvious to the examiner so you can start picking up those marks even if something's gone wrong. So 2.585 there over 2. So I just need to change out my calculator, delete, and bring him over here, delete him. And that was gone, look, it's gone just above 508, blah, blah, blah. Okay, so I'd say less than 4.5 here, and I'd say greater than 4.5 there, and I'd say one solution is above 4.5 and one is below, and one solution below 4.5, theta 3 equals 2.58 to 2 dp. Okay.